Hi, and welcome to this 8th video on intermediate Python. So in this video I want to talk about type hints. So type hints, which are also sometimes called type annotations, are a way in Python to indicate what kind of type something is. So as you probably know, Python is a dynamically typed language, meaning that, for instance, variables can change their type during the execution of a program. But still in Python one can use type hints to give indications of what something should be. For example, what type of object a function should return or accept as parameters. So this is a pretty straightforward topic, so let's head into a Jupyter Notebook to see how this works. So here we are in Notebook. As I said, in Python we can use type hints, or what's called type annotations, to hint at what the data type of something should be. So to try to motivate this, let's see what could go wrong by just not using type hints at all. So down here we can see that we have some function called append integers to list. It takes some value to append, a list to append to, and finally a parameter of whether you should remove previous instances of the value in the list. So let's see how this works by trying it out. Let's make a list called nums. And here I can make 1, 2, 6, 4, 5. And then let's just call the new variable more nums. So here I'll use the append integer to list method. And let's append 6 to the list nums. And let's specify true. By specifying true here in the remove previous instances, I want to remove this number 6 here that is already present. But if I run this, first of all, I need to execute this so that I have the function available, and I can run it again. Seems to work, but now if I take and print this thing out, I get here none. So if we look at the function, I didn't really have an indication of whether this would modify the list in place or return a new list. Seems like it's kind of modifying it in place. So I should probably then just run this like this and then check out the original nums here. So here you can see that it has appended 6 at the end, so that's good, but it hasn't really changed this number 6 previously. So I thought since I specified true, this would be removed, but it turns out that's not the case. So now we actually need to go down into the function definition and see what's happened. And if you look here, it really says if remove previous instances is equal to yes, not just true or false, then you'll remove all the previous ones with the while loop, and then you'll do the append method for the value. So that's kind of stupid, but that's the way people wrote this here. It doesn't make sense to specify true here. I would need to specify yes, running this again, and running this again, I get what I want. The problem with this whole thing here is this took a lot of time to debug something pretty simple. I think we can all agree that just appending a number to a list is super simple, but still I needed to go into the function and read the source code. I couldn't just apply it as a black box because I didn't really understand that I needed to specify a string here, not just a Boolean value. And I also didn't understand that this modified it in place and not that it would return me a new list. And it's kind of convenient in this example that I have the source code like right here, but usually it's a bit farther away from you. You need to go into a new file maybe and so on. So that makes it so that this will actually take up some minutes of your time, and that's super annoying. And one way to make your functions more understandable is to use type hints. So down here I have a new version. So you can see it looks kind of similar. So here I've called it value collection and remove prev, and not the more verbose versions. That's a minor difference, but the big difference here is that I've used type hints, and that's these kind of things here. So let's try to spell out what this is actually saying. This is saying that the value should be an integer. This is indicating to the person using the function that, hey, you should pass in an integer here. The collection should be a list of integers. The remove previous ones, I thought the yes thing that I did previously was stupid, so I should just have a Boolean value, true or false. Here I'm indicating that this is a Boolean value and the default value is false. And then finally, here I'm indicating with this arrow and none that this returns none. And that's a strong indication to me that this modifies the collection in place. So it doesn't make sense to assign the function call to a new variable. Just by seeing the function top here, I know a lot more about what should be passed into the function and what I can expect to get out of it. And in loads of cases, that's enough. Then you can treat the function as a black box and you don't really need to understand the internal logic. Of course, here the internal logic is pretty simple, but in more complicated cases, functions can be quite involved and of course call other functions and so on. So many times when using a function that someone else has written, you don't want to understand all the internal complexities, you just want to call the function as a black box. And by providing type hints, you make this a lot more simple. So as you can see here, the general format is that you can specify with a colon and then the data type, so for instance int, or you can also specify something like a list of ints. So this notation is also valid, and here again you can specify a boolean value, and then you can say, yeah, default value should be false, and finally you can specify this arrow to none or arrow to whatever, specifying the return value of the function. So in this video I didn't want to focus on the syntax because the syntax is pretty simple, you can just look it up. I wanted to focus on why we're doing this, and why we're doing this is to make functions easier to call as a kind of third party who hasn't written the function. And this of course happens all the time when you're writing code because you're borrowing functions from other libraries and using them, and you don't necessarily want to understand all the complexities of that function. So I just want to mention that you can also use type hints to variables in Python. So I can just make some variable name, let's just be a bit lazy and call it my variable, and assign it to 5, but I can also say, yeah, this is an integer. This is to indicate that it is an integer. Honestly, just personally, I almost never use this because for me, in this context, when you're doing an assignment, it's pretty clear the data type. So here I don't really see the added value of specifying a type hint compared to not doing it. So just a personal preference here, I don't do it, but you can do it as well. For me, the major advantage of type hints is with functions. I also want to mention that there is a typing module. So in Python, there is a built-in module called typing. As you can see, I'm importing from here, and the typing module has some more cool type hints that you can use. You can look up the module and see what's inside, but here I just wanted to show you two of them. One of them is called union and the other one is called optional. Union, as the name suggests, allows you to have more than one possible value. This is a new version of append value to list, and then for the value, you can have a union of integer, strings, or none. That means that anything you can pass in here, you have indicated that should be an integer, a string, or no value. The second one is optional, and this is just a shorthand notation for either the data type you pass in or none. So for instance, here in the collection, you should have a list that has ints, but by specifying it like this with optional int, you're saying that, yeah, it can be an int, but it can also be a non-value. So these are two more that you can combine to make more complicated expressions. I sometimes use union and optional. There are more useful ones inside the typing module, but you can just go and check it out and see if you find anyone that is particularly useful. Finally, I want to mention that in basic Python, nothing really happens if you violate the type hints. They're just really as hints, you could say. So again, let's just have a list. 1, 2, 3, 4, 5. That's pretty simple. So let's just make sure we have run this so that we're sure we have this version here. And now I can use append value to list. This is the function here. So let's see what I can pass in. For the value, I can pass in a tuple with the values 17 and 5. And for the collection, we can do nums. And now you should be like, wait, that's not an integer value or a string value, and you're completely correct. But the thing is that this is completely allowed. So if I now print nums, I've just inserted here a tuple into my list. So notice that these type hints, they don't prevent anything from happening. In base Python, they are just hints. They're hints to people using your code saying that, hey, this is what you should pass in. I would like to note that there are external tools, what's typically called static type checkers, that go into your Python code and check that everything that is passed into functions are really in conjunction with these hints that you've specified. The most common one is called Mypy. I can give you a link in the description of the video. And there are many people who use Mypy, for instance, in CI/CD pipelines for automatic code checks. And that's something you can do, but really here I'm trying to highlight the value of type hints independently of type checkers. For me, type hints, the most valuable thing about them is that they give this great indication of what kind of data types should be passed into a function, and also what type of object a function returns. Especially here when you see return none, then it's a pretty big indication this either modifies an object in place or maybe makes a call to a database or a web server or whatever. So in this case, it doesn't give you anything to capture the return value of the function in a new variable. So that's really what I wanted to say about type hints in Python. They're super useful. Again, if you want to get started doing this, then just try it out. And you can of course just search a bit around and see how you can specify this precise syntax. I didn't want to focus on this in this video because I think the idea is a bit more important. So I hope you learned something, and I'll see you again soon.